My name is Chandrachur Malik. My roll number is 001610701063. I did this project on DRDO Integrated Test Range, Chadipur Balasar on 2019 summer training. I did my project on telemetry system. Before getting into telemetry system, I would like to briefly discuss what DRDO is about. The full form of DRDO is Defense Research and Development Organization. It works under Department of Defense Research and Development of Ministry of DRDO dedicatedly by working towards enhancing and development leading to production of world-class weapon system and equipments. Let's get into the telemetry system. Telemetry is a concatenation of two words which means tele means far and meter means to measure. So telemetry is the making measurement of far away objective which is not reachable by human, or it also means to measure an object which is an environment which is unreachable by us. For example, if we want a measurement which is inside supersonic wind tunnel, we require telemetry to measure the parameter. Nowadays, we use telemetry to measure the parameter of missile or rocket or vehicles testing or space aircraft. The medical profession extended the definition of telemetry to include the measurement made to monitor a human subject and to remote central localization. So basically, it is telling that telemetry is a health parameter. It is basically used to monitor physical characteristics such as temperature, pressure, speed, flow rate, liquid level. The sensitive transducers convert these physical characteristics into electrical signals. The electrical signals are then processed in various ways and sent to the central monitoring location for the purpose of determining their status and operational condition. Then to monitor a guide missile and analyze the health parameter, DRDO has developed different kinds of telemetry and telecommand system. VCM telemetry system 1533 based ASIC, PCM encoder, digital telecommand system, C-band transmitter, S-band transmitter, CDMA data link, confrontal antenna system. Digital telemetry antenna is used, which is located near Charipur Sea Beach to receive the signal from the missile during the test and analyze the signal. That means the different type of uh, different types of telecommands are being used to guide and analyze the missiles and rockets. Basically, it is calculating as the health parameters. In the telemetry section, we have designed an antenna with own parameter and when found its gain to noise temperature, have designed a 6-step of digital filter. Beside this, we have also analyzed the link budget of antenna, super heterodyne receiver, up converter and down converter. So here is the receiving stations. So let's discuss about this diagram. In the given diagram of the receiving station, in the antenna is used as a wireless communication which is provided with a remote site from the transmitter output signal into RF signals. Low noise amplifier is used to amplify the weak signal which are being received by the antenna. Down converter. It converts a band limited signals to a lower frequency at a lower sampling rate in order to simplify the subsequent radio stages. The input and output signals can be real or complex samples. Multicoupler. It is used to convert it is used to connect the multiple radio receives to a single antenna. It splits a single into a singular, that is, it receives from the antenna into a multiple signals with high port to the port isolation. Bit synchronization. It is used to ensure that signals transmitted from one participant of the communication can be correctly decoded by the receiver. Then decommutator. It is the important subsystem at the ground station in the telemetry. So here it is as I have told about the antenna, the low the amplifier, the down converter, multi-coupler with synchronization, and the decommutator. So then get into the super heterodyne receiver. Here is the super heterodyne receiver. The super heterodyne receiver, it basically converts every selected radio frequency to a fixed lower frequency called as intermediate frequency. The process of mixing two signals having different frequency to produce a new frequency is called as heterodyne. So here the receiving antenna, the amplitude modulation signal transmitted in the form of electromagnetic waves. When received, it induces a small voltage in the receiving antenna. The radio frequency stage, it selects the required signal and rejects other signals. It reduces effect of noise. Mixer, it receives two input in the form of predicted frequency and the form of local oscillator. Local oscillator is said to be f0 and fs is said to be the radio frequency. The local oscillators are always greater than the regular frequency. And then let's talk about the intermediate frequency, which provides gain to the receiver. The sensitivity of the receiver doesn't change with the change in the incoming of frequency. Then the demodulator, this type of radio receivers which uses frequency to convert or receive signal to a fixed intermediate frequency, which can be more conveniently processed than the carrier frequency which was originally. So then so these are the three advantages of using the super heterodyne receiver, that is a better selectivity at zero intermediate frequency. There will be no image frequency and low flicker noise. Then it's chapter 3, then we got into the antenna gains to noise temperature ratio. So the antenna gain to noise temperature ratio, GBIT, usually defined with respect to the earth station receiving antenna, and is an indicator of the sensitivity of the antenna to the combined downstairs carrier signals from the satellite. It is a figure of merit used to indicate the combined performance of the earth station antenna and low noise amplifier combined in receiving weak carrier signals. So basically, let's see what antenna is being told in this. The properties of the antenna are the antenna gain, aperture directivity, and bandwidth, polarization, effective length, and polar diagram. And here is the antenna gain, which is the formula of power radiated by the antenna by the power radiated by the reference. And then there is directivity and bandwidth. The activity of an antenna is defined as the measure of concentrated power radiated in a particular direction. It may be considered as the capability of an antenna to direct radiation intensity in a given direction to the average radiation intensity. Bandwidth is one of the desired parameters to choose an antenna. It is defined as the range of frequency over which an antenna can probably properly radiate energy and receives energy. This is equal to here is the formula of the directivity and bandwidth. So noise temperature. So uh, noise temperature, it is to measure the noise entering the receiver via the antenna. The antenna picks up noise radiated by various man-made and natural sources within its directional pattern. So the noise figure F is S in by S in S in by N in by S in out by N out, and this is the formula of the noise temperature. T is equal to F minus 1 of the of ENV. So these all are the formulas and the link budget. And here it is the up and down converters. So in up and down converters, if the frequency is of 41435, then it will, if it is a down convert, it will convert into this lower frequency, and if it is up converter, then it will increase its frequency. So then let's talk about the block diagram and representation of high gain telemetry system. In high gain telemetry system, uh, and an antenna receives the signal, because we know in telemetry system no signal is transmitted from antenna, in other it only receives the signal from missile. This is different from the radar. At receiving system, many operation will done. Many operation means filtering missiles, etc. The output of the receiving system is intermediate frequency signal. Because of redundancy, there are three receiving systems which work parallel. If one receiving system is somehow damaged or misbehaved, the other system come on the picture, because we don't want to take any risk. Now the intermediate frequency come to record the data. There are two types of recorder which works parallel. Because of redundancy, we can store cat and every bit of information at every second. Now the now the signal to decorum the circuit which associated with the PC, there were PC and the decorum the signals to telecommand or safety units. The gain of the antenna is very high. And then we have simulated a design using the AWS software. We made a patch antenna. So here with the patch antenna, basically patch antenna, it is a metal patch placed in a dielectric material and supported by the ground plate. It could be easily fabricated on printed circuit. And then it is the patch antenna. This is the patch view, and this is the 3D view, and it is the validation checkpoint, and this is the gain, as we can see in the figure. So here is the radiation pattern. The upper figure is of the front view and the lower figure is of the side view. Then the graphical view of the radiation pattern. There are two types of pattern which we can see. One is a 49, both are of 1400 megahertz. Then the optimization. Then we have also designed a super heterodyne receiver. So basically, super heterodyne receiver is a type of receiver that uses frequency mixing to convert and receive signal to a fixed intermediate frequency, which can be more conveniently processed than the original carrier frequency. A super heterodyne receiver uses the same heterodyne principle, but instead of using an audible frequency, a lower intermediate frequency above the hearing range, then is easier to process by an analog electronics. So it is the FET characteristics, and this is the filter response, the output spectrums, and the output voltages, voltage forms overview, power budget analysis. Then we have designed the HFSS software. By using the HFSS software, we have designed the microstrip patch antenna, and so this is the diagram, and it is the front view of the patch and the microstrip patch antenna, and this is the back view. The S parameter graph is being plotted, and the VSWR plot is also there. So basically, from this summer training, we came to know how the telemetry system works. We simulated patch antenna using the AWS software, super heterodyne receiver by using by HFSS software, and made microstrip patch antenna. Thank